Hello everyone, this is Productive Cloud Innovation. So today we are talking about our last section in fallacies of distributed systems. So in this fallacy, Mark Richard is with us, and he's going to discuss more about the transport cost and also the network and homogeneous nature of the network. So Mark, it's up to you. Please go ahead.
All right. Thank you, Rohit. And this has been wonderful being in your podcast and being able to talk about these fallacies, which are things that we believe to be true, which are not. As a matter of fact, exactly the opposite. We've got two more to talk about, and this has been quite an interesting journey. I want to talk about fallacy number 7 in this podcast, and also 8, but I'll follow on 8 afterwards. Fallacy number 7 states transport cost is 0. This one's used to be, back in the day, one of the most confusing ones, because a lot of people consider transport cost latency. But no, what this fallacy is really pointing to is the fact that when you start breaking apart applications, either into cloud native or maybe a 12-factor app to be able to deploy in cloud, necessarily it does require us to break apart our monolithic, or especially our large monolithic applications. Mm-hmm. And we just make the assumption, well, if I break apart my app into 5 or 6 different pieces and just make some RESTful calls, I mean, what's the big deal? I mean, it's free, right? And that's what this fallacy is really saying. No, it's not free. There are costs associated with distributing our applications. A lot of times those costs may come from extra network equipment, extra routers, maybe it's extra web servers, maybe additional servers. As a matter of fact, if we're going to communicate between 2 services, for example, using gRPC-LB, that requires us, and that's Google's remote procedure call with the load balanced protocol, that necessarily requires us to have a load balancer that's gRPC-LB aware. And Traefik, Traefik, is one such load balancer, but this is now incurring additional cost, not only from licensing, but also server space to put that on. And so that's really the significance of this, is just there are costs, sometimes hidden, money-wise costs, kind of associated with distributing our applications. And this is actually my second favorite fallacy, because I've gotten bitten on this before as well, not budgeting in those costs.
Yeah, I get that, Mark. Like, do you see any other thing might be there? Like, I see that, like, any other cost might be there associated with it, like, when we are doing processing of data, costs with that, and also association with the, if your previous example, when you were talking about the APIs, only get one data at a time. So if you're getting all the data, if for a given object, that there's a cost of serialization, deserialization. So all those adds up. So any thoughts on that?
Yeah, that's a really good perspective and observation, Rohit, that, I usually interpret and also exercise fallacy number 7, transport cost is 0, and in terms of the actual dollar money costs associated with distributing our applications. But you bring up a really, really good point. There is another perspective to the transport cost, and that occurs with, for example, serialization that we don't have within making a simple method call that we now do have when we're making a remote call. So yes, that is that's actually a pretty cool perspective, that would be different than actually the actual monetary cost associated with it, because now we're incurring additional processing time. And like you said, that's going to impact fallacy number 2. Latency is 0. As a matter of fact, it could even, to your point, impact fallacy number 3, bandwidth is infinite. And so, yeah, that's a really good perspective. There is one last fallacy to talk about in this series, which has been great, and that's fallacy number 8. The network is homogeneous. No, it's not. As a matter of fact, the network is probably as homogeneous as your layered stack, all the various jar files or the NuGets you've done for the DLLs you've added. It looks like a hodgepodge, and that's exactly what the network looks like. I usually challenge, as a matter of fact, I've got I've got these props I use, Rohit. They're an actual, not actual, but it's a US $1 million bill.
I know. Nice.
And I usually do this fun game when I'm at a client where I'll say, look, I will bet you $1 million US that you have at least 3 network hardware vendors in your topology. In other words, maybe you've got some Cisco, maybe you've got Linksys, maybe you've got some old Bay network routers. And the point is, I still have my $1 million. It's a very safe bet. And here's the question. Do all those different network hardware vendors, all that equipment play well together? Has it all been fully tested? And the answer I usually get is, well, Mark, it doesn't need that because we're applying standards. I mean, there are standards that all these network vendors apply, but even if we do apply the standards, we still apply standards in our software development. Does that mean our software has 0 bugs? No, the answer is not. Packets do get lost because sometimes these network hardware vendors don't necessarily 100% play together well. So the assumption that we make that everything's homogeneous is not true. It's heterogeneous. And all those different kinds of, let's say, network devices from different vendors sometimes don't play together well. And here's the cool thing, Rohit, because most people say, yeah, whatever, but how should that impact me as a developer for distributed cloud native applications or as an architect designing these? Here's how. Because when you have heterogeneous networks, sometimes that equipment does not play together well. And this, therefore, impacts reliability. That's fallacy number 1. It impacts latency. That's fallacy number 2. It impacts bandwidth, fallacy number 3. And the fact of fallacy number 5, that the topology always changes. As a matter of fact, Rohit, it even impacts fallacy number 4, that the network is secure. Because if we have another firewall come in from a different vendor, does it have the same security profile as our prior one? And all of a sudden, we may have just introduced a security hole in our network. I love this one because it just ripples down. So now we're down at fallacy number 8. And what happens, Rohit, it just starts whittling down and cycling through all the other fallacies. That's why this one's significant. You know?
Yeah, that's great. Like, I mean, I use them like, just from the architecture evaluation purpose, like, when we're doing evaluation, and what all are the places where people can use this?
Mm-hmm.
What do you think? What all are the stages, like, in development? What do you think? Like, is it an architecture inspection, or like, what do you suggest? Like, when can we use this? Like, what all are the places you think?
Well, I'm gonna be flippant and say every stage. Even so you might think, well, this is all has to do with networks, so it's all to do with the administrators, or an architect should deal with these. Yes, an architect absolutely has to know these cold. I mean, know every single one of these, which is why these are so critical. But I would go as far as to say every stage, because as a developer, I may make a choice to split a service into 2 that needs to communicate. Now, as a developer, I need to be aware about latency and security and the responsiveness about those. I need to be concerned about the bandwidth. And so and also reliability, because you see, one of the things that this whole thing kind of wraps up now is the fact that these all play in distributed computing. Even though they were coined in 1994, Rohit, they are 100% applicable today, every single one of them, especially when we start talking about microservices. And so the point is, where we get into trouble is not knowing these. And that's from a development, design, architecture, even an analysis standpoint. My opinion is all stages. I challenge anybody, any team I'm working on, any company I'm doing advisory consulting, to understand, memorize, and be able to recite all 8 fallacies in order. And it's something then that gets always in your mind and always thinking about these kind of problems, because again, this is where we get into trouble. Whether it be cloud, whether it be on-prem, distributed computing is really, really hard. And I think these 4 podcasts have kind of demonstrated some of that.
And then to back you up, like, we say like, oh, it's only from the development. So testing also is very, very critical. Like, when we are
Yes.
testing this, like as you said, it's like all the levels. So including security is just one part of it, but like to test, like, chaos engineering, or, getting
Yep.
into, uh, getting into breaking the network and then seeing that it still functions. Like, Netflix does that, like, pretty much like
Wow.
in a game, like AWS provides like, game days for this kind of thing. Like, you have a game, so you're playing a game. That's what I like about it, like a chess game.
So, wow, what an excellent point. Sometimes we see and we test responsiveness, and then we have to drill down. Did we introduce additional latency or additional calls? But you make a really good point, Rohit. Never have I seen a test yet to determine what bandwidth utilization have we increased or decreased this iteration.
Yes.
Now, that would be really hard test, and it would involve a lot of collaboration with network administrators. That was fallacy number 6. But yeah, that's an extremely good point. These are things that sometimes we don't test.
Mm-hmm.
Yep.
Yeah, exactly. And, and maybe that could be a separate podcast, but like, from the testing perspective, if you think about it, if we capture all the data, like, a slice of data for this build, this is what my KPIs are, key performance indicators are, and this is what my bandwidth, this is the network time, this is the performance, and this is all through JMeter or some test which we are running it. We capture it, put it in Grafana, it's all ready for us to compare. And then we can actually do the comparison with the previous build and say, oh, is there any latency here or not? But I see, like, that's something, an awareness, like a separate podcast to discuss.
Yeah.
How
Well,
to.
it certainly is an important topic, because especially when we talk about things that we don't think about measuring, for example, like the bandwidth, we may have had in this iteration to make 3 additional service calls.
Mm-hmm.
Based on the number of calls that we're making on a per second or per minute basis, based on the fact that we're just making that RESTful call and now introducing stamp coupling, functionally it works just fine. And as a matter of fact, it seems to not impact responsiveness that much, but all of a sudden maybe we've significantly increased bandwidth.
Yeah.
And that won't really sometimes come to fruition until we end up in a spike or a peak and everything just kind of stops. And all of a sudden it's like,
Exactly.
yeah, we ran out of network bandwidth. And we don't
Exactly.
pay attention to it.
Mhm.
Kaboom. Yeah, fantastic. Good,
So,
great observation.
yeah, on the same line, it was like, you were discussing, like, one of the thing which people say that, oh, I'm just adding 3 services. Are those 3 services is serial or parallel?
Mm-hmm.
If they are serial, you are actually decreasing your availability. So net availability is going down, no matter, like, whosoever is your slowest, service is making this, the availability, the overall availability is going down, because depending upon the different service at any given time. But if you're doing in parallel, then it is fine, because you're increasing the availability. So I think that's
Right.
that's also people can, look at.
Yeah. Lots of trade-offs with that. Yep.
That's true, and yeah, great. So, well, we today discussed the last part of our fallacies of distributed system. I really thank you, Mark Richards, for providing us a great guidance on this, and I had a great time talking to you.
Yes, thank you. You too, Rohit.